Hello, welcome to today's lesson. We are looking at cubes and cube roots. Previously, we've looked at the squares and square roots. So now we want to look at cubes and cube roots. So to start with, let us find out what is a cube. When we were looking at a square, we simply said that a square is that number that is multiplied by itself. So when we multiply 4 times 4, it gives me a square, which is 16. So when you multiply a number by itself twice, then we have a square. But supposing I multiply this number repeatedly 3 times, so it is repeating itself 3 times. So I have 4 times 4 times 4. When it is repeating itself 3 times, so it is repeating 3 times, then whatever we have is a cube. So 4 times 4 times 4 gives us a cube. So if I have 4 times 4 times 4 is simply 4 times 4 is 16, then 16 times 4 gives us 64. So this 64 is a cube. So a cube is simply that number that is obtained when a number is multiplied by itself 3 times, repeatedly 3 times. So we are repeating multiplication 3 times. How do we write a cube? The number is repeating itself 3 times, and from our indices instruction, when a number is repeating itself, you just count how many times is the number repeating itself. The number of time it is repeating itself gives us our power. So in this case, I have 4 times 4 times 4, so my base is 4. Then, how many times is the 4 repeating itself? That is 1, 2, 3. So, the 4 is repeating itself 3 times. So, we have 4 cubed. So, when you see a number that has been written to the power of 3, so a number written to the power of 3 simply asks you to find the cube of that given number. So, 4 to the power of 3 is 64. So instead of writing 4 times 4 times 4, I can simply write 4 cubed is 64. So a cube is that number that is obtained after multiplying the number repeatedly 3 times. So you are having the number repeatedly multiplied 3 times. Then whatever you are having is a cube. So let us look at some few examples that evaluate. The first one I have to evaluate is 6 cubed. The second one is 11 cubed. The third one I have 20 cubed. Then I have 8 cubed. And finally we have 15 cubed. So how do I get the cubes of these given numbers? We are saying that a cube simply means that we multiply the number repeatedly 3 times. So these I have 6 times 6 times 6. 6 times 6 is 36. So that means I have 36 times 6. So 36 times 6 from our multiplication algorithm, we will have 6 times 6, that is 36, right? 6, carry 3. 6 times 3 is 18. 18 plus 3 is 21. So 6 cubed simply gives us 216. Next we have 11 cubed. I'm sorry, it is not a square but cube. We are getting cubes of numbers. So 11 cubed. 11 cubed means that we get 11 3 times. We multiply 11 repeatedly 3 times. So that is 11 times 11 times 11. 11 times 11 we all know is 121. Then 121 times 11. So we go through our multiplication algorithm and we get that 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. Then 1 times 1 is 1. 1 times 2 is 2. 2 times 1, 1 times 1 is 1. So when we add, we have 1 plus 0, which is 1. 1 plus 2, that is 3. 1 plus 2, we have 3. Then this is 1. So it simply means 11 cubed is 1000. 1,331. So 1,331 gives us the value of 11 cubed, or it is the cube of 11. The next sum we have is 20 cubed. 20 cubed, it means that I'm multiplying the 20 3 times, repeatedly 3 times. So I have 20 times 20 times 20. 20 times 20 is 400. 400 times 20. 4 times 2 is 8. Then I have the 3 zeros. So it means that 20 cubed, or the cube of 20, is 8,000. Next, I have the cube of 8. Cube of 8. Cube of 8, it means that I multiply the 8 repeatedly 3 times. That is 8 times 8 times 8. 8 times 8 gives us 64. Then 64 times 8. So 64 times 8 will give us 8 times 4 is 32. Write 2, carry 3. So we have 8 times 6 is 48. 48 plus 3 is 51. So 8 cubed is simply 512. Next we have 15 cubed. So 15 cubed, what is 15 cubed? 15 cubed is simply 15 repeatedly 3 times. So 15 times 15 times 15. 15 times 15 is 225. Then we multiply by 15. So 225 times 15. We get that 5 times 5 is 25. So write 5, carry 2. So I'm carrying my 2. 5 times 2 is 10. 10 plus 2 is 12. So write 2, carry 1. Then 5 times 2 is 10. 10 plus 1 is 11. Next I have 1 times 5 is 5. 1 times 2, 2. 1 times 2, 2. So that means when I add, I have 5 plus 0, which is 5. 5 plus 2, which is 7. 1 plus 2 is 3. 1 plus 2 is 3. So it means that 15 cubed is 3,375. So when you are asked to get a cube of a given number, it simply means that you go ahead and multiply that number repeatedly 3 times. So repeatedly the number, when you repeat multiplying the number 3 times, then what you are getting is the cube. So still with the cubes, you can give your answer either in index form. So we have the cube in index form, or the cube can be given as a basic numeral. So you can have either the cube in index form or as a basic numeral. What do I mean with the cube in index form? I can use the example of the first 10 digits we have that we need to get their square root, their cubes. So the first 10 in index form, if I have to write the cube in index form and write the cube in as a basic numeral, and I'm using the first 10 digits. So in index form, the first 10, the first one I'm having 1 cubed, the second one is 2 cubed, the third one is 3 cubed, then we have 4 cubed, we have 5 cubed, then still in index form we have 6 cubed, then we have 7 cubed, we have 8 cubed, 9 cubed, and 10 cubed. So this is in index form. So we have index form and as a numeric, a basic numeral. So when you are writing in index form, it simply means you show the sign for the cube. And we've said that the sign for the cube is the power of 3. You write your numbers to the power of 3. Then you will have written in index form, the cube in index form. But as a basic numeral means that you simplify your answers. So if I'm having 1 cubed simply means that I multiply 1 times 1 times 1. And 1 times 1 times 1 is simply 1. Then 2 cubed means that I multiply 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. Next we have 3 cubed. 3 cubed is just 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 4 cubed, I have 4 times 4 times 4. 4 times 4 is 16. 16 times 4, we have 64. 5 cubed is 5 times 5 times 5. 5 times 5, that is 25. 25 times 5 is 125. Then this we have 6 times 6 times 6. 6 times 6 is 36. Then we have 36 times 6. 6 times 6 is 36. 6 times 3, we have 18 plus 3, that is 21. So 6 cubed is 216. 7 cubed simply means 7 times 7 times 7. So 7 times 7 is 49. 49 times 7, we will have 7 times 9, that is 63. So write 3 carry 6. 7 times 4 is 28. 28 plus 6, we have 34. 28 plus 6 is 34. So 7 cubed is 343. Then 8 cubed simply means 8 times 8 times 8. So 8 times 8 is 64. 64 times 8, we have 4 times 8, that is 32. Write 2, carry 3. 8 times 6 is 48. 48 plus 3, we have 51. So 8 cubed is 512. 9 cubed is 9 times 9 times 9. 9 times 9 is 81. 81 times 9. 1 times 9 is 9. 8 times 9 is 72. So 9 cubed is 729. Then we have 10 cubed. 10 times 10 is 100. Then 100 times 10 gives us 1,000. So 10 cubed is simply 10 times 10 times 10, which gives us 1,000. So that is how we write numbers either in index form or as a basic numeral. So when you are asked to give your answer in index form, then it means you leave it as a power of 3. If you are asked to give your answer as a basic numeral, then it means you simplify. Go ahead and multiply that given number repeatedly 3 times and find out what the answer will be. So this is in index form and this is as a basic numeral. So next we need to get the cube roots. We've started by defining what a cube is, and we said that a cube is that number that is obtained when you multiply a number by itself repeatedly 3 times. But now we are we want to get the cube root. Then it means a cube root is now that number that when I multiply the number repeatedly 3 times, I will get the cube. So what does it mean? A cube root is simply the reverse of the cube. So when you are getting the reverse of your cube, then what you are getting is the cube root. So cube root, how do we get these cube roots? First, before we look at how we get the cube roots, the symbol for a cube root, when you see this symbol, then it means that the question is asking you to get the cube root. So the symbol for cube root is almost the same as that one for the square, but the difference is this one has a 3 on it. So when you see this sign, then it means what you are finding, you are simply being asked to get the cube root of that given number. So how do we get a cube root? Let us look at some of the examples on how we get cube roots. So evaluate. So we are getting the cube roots of these numbers we have on the board. So how do we get the cube roots? So this is how we go about. When we were getting square roots of numbers, for instance, I'm asked to get the square root of 16. So if I'm getting the square root of 16, then what we said is look for the prime factors of 16. And the prime factors of 16, we are starting all the way from 2. So we had 2 into 16, 8, 2 into 8, 4, 2 into 2 into 4, 2, 2 into 2, we have 1. So what does it mean? The prime factors of 16, we have 2 times 2 times 2 times 2. Then I want to get the square root. So square root, we said that it is a number that is multiplied by itself so that you get the square. So in this case, a number that is multiplied by itself, we have 2 times 2, we have 2 times 2. So repeatedly, 2 here has been multiplied by itself. So the square root in that case is 2. The square root in this case is 2. So the square root of 16 will be 2 times 2, which is 4. So this is the square root. But now, I'm not looking for the square root. I'm looking for the cube root. Still for the cube root, we will get the prime factors of the number. So we get the prime factors making up the number. But how do we get the cube root? Cube root is that number that is multiplied by itself repeatedly 3 times. So we are getting the number that is repeating itself 3 times. So what number is repeating itself 3 times? So we are looking at the examples we have on the board. The first example I have is 64. So getting the prime factors of 64, we get that 2 into 64 is 32. 2 into 32, we have 16. 2 into 16 is 8. 2 into 8 is 4. 2 into 4 is 2. And 2 into 2 is 1. So repeatedly, 2 has repeated itself 6 times. So it means the prime factors of 64 is 2 times 2 times 2 times 2 times 2 times 2. So we are having 2 repeating itself 6 times. Then the cube root is that number that is multiplying itself repeatedly 3 times. So I want to group my 2's in a manner that I'm having the 2 repeating itself 3 times. So the 2 repeating itself 3 times. This is the first group, then the 2 repeating itself 3 times. So it means the cube root in my first group will be 2. The cube root in my second group is 2. So the cube root of 64 will be obtained by 2 times 2. 2 times 2 is 4. So it means that our cube root for 64 is 4. Let us just prove to find out, is it true that if I repeat multiplying 4 repeatedly 3 times, I will get 64. So I'm having 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So it then automatically means that the cube root of 64 is 4. So it is true that the cube root of 64 is 4. Part B, I'm supposed to get the cube root of 8. So cube root of 8, what are the prime factors making up 8? So the prime factors, the first one is 2. 2 into 8, that is 4. 2 into 4, we have 2. 2 into 2, we have 1. So it means the prime factors making up 8 is 2 times 2 times 2. But we are looking for cube root. Cube root is that number that is repeating itself, repeated multiplication thrice. So we are having these 2 repeating itself 3 times. So it simply means that since my 2 is repeating itself 3 times, then the cube root of 8 is 2. Let us prove to find out. 2 times 2 is 4. 4 times 2 will give us 8. So it means that the cube root of 8 is 2. Next, I'm having to get the cube root of 1 million. 1 million is a power of 10. So being a power of 10, instead of going through the method of finding factors, we can group them into those powers of 10. So 1 million, simply 1 million, 1 million. So I have 1 million, 1 million, 1 million. This means that 1 million, we are having powers of 10. And this one is power of 10. It simply means that I have 10 to the power of 6 if I write it in index form. 1 million is the same as 10 to the power of 6. So I'm having my 10 repeating itself 6 times. So I have 10 times 10 times 10 times 10 times 10 times 10. So it is repeating itself 6 times. After it has repeated itself 6 times, so we are having repeated multiplication 6 times, I can group it in a way that we are having the 10 repeating itself, its multiplication 3 times. So we have where 10 is repeating its multiplication 3 times, that is the first group, then this is our second group. So what is the cube root in the first group? This is cube root and not square root. So cube root in the first group, 10 times 10 times 10, my cube root will be 10. Then the second group, 10 times 10 times 10, my cube root is 10. So this means that the cube root of 1 million is simply 10 times 10. And 10 times 10 gives us 100. So it means that the cube root of 1 million is 100. Just to prove, let us multiply 100 repeatedly 3 times and find out. So we have 100 times 100 times 100. 100 times 100 is 10,000. We simply add the zeros. These are 4 zeros. So this is 10,000. Then we have 10,000 times 100. So we add the 2 zeros on our 4 zeros to make it 6. So we have 1, 2, 3, 4, 5, 6. So that gives us 1 million. So since 100, if I multiply it repeatedly 3 times gives me 1 million, then we conclude and say that the cube root of 1 million, cube root of 1 million is simply 100. Then we have cube root of 3,000. The next one is 9,261. We are supposed to get the cube root of 9,261. So what are the prime factors making up 9,261? So 9, we find that in this case, 2 is not a prime factor because our last digit is 1 and 1 is not an even number. So we move on to 3. 3, we have 9 plus 2, which is 11. 11 plus 6, that is 17. 17 plus 1, we are having 18. So 18 is a number that is divisible by 3. Being the fact that it is a number that is divisible by 3, then it means that my first prime number is 3. So 3 into 9, that is 3. 3 into 2, we have 0. 3 into 26, we have 8 because of 24. So we are left with 2 into 21, we have 7. Let us find out. Automatically 2 is not a prime number. So we are still with 3. Let me confirm. 3 plus 0 is 3. 3 plus 11, 3 plus 8 is 11. Then 11 plus 7 is 18. So 18 is a number that is divisible by 3. So it means my next prime number is still 3. 3 into 3, 1. 3 into 0, 0. 3 into 8, 2. Because of 6, we are left with 27 into 27, that is 9. Let me find out if this number is still divisible by 3. So I have 1 plus 0, that is 1. 1 plus 2, the 3. 3 plus 9 is 12. So 12 is a number that is divisible by 3. So it means I still continue with my 3. 3 into 1, it can't be divisible by 3. So I make it 10. 3 into 10, we have 3. I'm left with the remainder of 1, so I make this 12. 3 into 12, we have 4. And 3 into 9, that is 3. So still, let me find out if my number is divisible by 3. So 3 plus 4, that is 7. 7 plus 3, we get 10. So 10 is a number that is not divisible by 3. It means that up to that point, that is where my 3 will end. So I find out another number that is divisible by 3. We find that 5 cannot be divisible by this number. This number cannot be divisible by 5, because our last digit is neither 0 nor 5. So I can't use 5 as my next factor. From 5, I have 7. Let me confirm if my number is divisible by 7. 7 into 34, we have 4 because of 28, and we are left with 6 into 63, that is 9. So it means that my next prime number that I have is 7. So 7 into 34, we've already said it is 4 because of 28. So we are left with 63 into 63, we have 9. Then 7 into 49 is 7. And 7 into 7, we have 1. So the prime factors making up 9,261 is 3 times 3 times 3 times 7 times 7 times 7. So we are getting the cube root, meaning I have to get them in groups of 3. So my first group of the number repeating its multiplication 3 times is 3 times 3 times 3. Then I have 7 times 7 times 7. So in this case, my cube root will be 3. The next case, my cube root will be 7. So I have 3 times 7, which gives us 21. So it means that the cube root of 9,261 is 21. I want us to confirm if I multiply 21 repeatedly 3 times, if it will give me 9,261. So I have 21 times 21 times 21. So 21 times 21. 1 times 1 is 1. 1 times 2 is 2. 2 times 1 is 2. 2 times 2 is 4. So when I add, I have 1, 4, 4. Then next we have times another 21. So when we multiply, we have 1 times 1 is 1. 1 times 4 is 4. 1 times 4 is 4. Then 1 times 2 is 2. 1 times 4 is 8. 1 times 4 is 8. So this means that when I add, I have 1 plus 0, which gives me 1. So 1 plus 0 is 1. 4 plus 2 is 6. 4 plus 8 is 12. So I write 2, carry 1. 1 plus 8 is 9. And we discover that if I multiply 21 repeatedly 3 times, I'm getting 9,261. So in conclusion, we are simply saying that the cube root of 9,261 is 21. So cube root of 9,261 is simply 21. The next number is, I'm supposed to get the cube root of 3,375. So let us find out what is the cube root of this given number. So I have 3,375. Let me look for the prime factors of this given number. So the first prime factor, 2, is not a factor because this is 5. 5 is not an even number. Our last digit here is 5, so 5 is not an even number. The next prime factor is 3. We simply add the digits and find out, is the sum divisible by 3? So when we are adding, we have 3 plus 3, that is 6. 6 plus 7 is 13. 13 plus 5 is 18. So it means 3 is divisible by, the number is divisible by 3. So I have 3 into 3, that is 1 into 3, 1 into 7, 2. Into 15, that is 3. Let me find out 1 plus 1, 2, 2 plus 2, 4, 4 plus 1 plus 1, 2, 2 plus 2, 4, 4 plus 3, 7. 7, yeah, sorry. 3 into 15 should be 5 and not 3. So that is where the problem is. So 3 into 3, 1. 3 into 3, 1. 3 into 7, 2. We have a remainder of 1. So this makes it 15. 3 into 15, we have 5. So let me find out. This is 1 plus 1 is 4. 1 plus 1 is 2. 2 plus 2, 4. 4 plus 5 is 9. So 9 is a number that is divisible by 3, so it means I continue with 3. 3 into 11, we have 3 times because of 9. 9, a remainder of 2, so we have into 22, that is 7 because of 21. We have a remainder of 1, so a remainder of 1 makes it 15. 3 into 15 is 5. Then let me find out, this is 3 plus 7, 10, 10 plus 5, 15. So it means 3 is still divisible by the number. 3 into 3, we have 1. 3 into 7, that is 2. We have a remainder of 1, which makes it 15. So 15, 3 into 15, that is 5. So let us find out, is our 3 still divisible by the number? We have 1 plus 2, that is 3. 3 plus 5 is 8. So it means that this number is not divisible by 3. So we move on to the next number in the divisibility test, and that is the next prime number. The next prime number we have is 5. So find out 5. Our last digit is 5, and a number is divisible by 5 if the last digit is either 5 or 0. So it means that my next number is 5. So 5 into 12, that is 2 because of 10. 5 into 25, we have 5. Still, we have 5. 5 into 25, that is 5. And finally, 5 into 5, we have 1. So it means that the factors making up 3,375 is 3 times 3 times 3 times 5 times 5 times 5. Grouping them, I have a group, then I have this group. In my first group, the 3 is repeated has repeated itself 3 times, so it means that my cube root in that case is 3. In my second group, 5 has repeated itself 3 times, so it means that the cube root in that case is 5. So I have 3 times 5, and 3 times 5 is 15. So what does it mean? It means that the cube root of 3,375 is 15. So the task we are left with is confirming. Is it true that if I multiply 15 repeatedly 3 times, I will get 3,375? So let us confirm. 15 times 15 times 15. 15 times 15, I'm having 5 times 5, that is 5. 5 times 1, 5 times 5 is 25, so we write 5 carry 2. 5 times 1 is 5. 5 plus 2, we have 7. 1 times 5 is 5. 1 times 1 is 1. So when we add, we have 5 plus 0, which is 5. 7 plus 5, that is 12, carry 1. 1 plus 1 is 2. Then multiply this one by 15. We have 5 times 5 is 25, write 5 carry 2. 5 times 2 is 10. 10 plus 2 is 12, so write 2 carry 1. 5 times 2 is 10. 10 plus 1 gives us 11. Then 1 times 5 is 5. 1 times 2 is 2. 1 times 2 is 2. When we add, we have 5. 2 plus 5, 7. 1 plus 3, 1 plus 2, 3. 1 plus 2, 3. So it means that it is true the cube root of 3,375 is, this is cube root and not square root. So if I write the number leaving out the 3, then it means that I'm looking for square root, but in this case we are looking for cube root. So the cube root of 3,375 is 15. So let us get the cube root of this number 2 and find out what will be our cube root. So we have the number 15,625. We need to get its cube root. So let's go ahead and get the prime factors making up 15,625. The first prime factor, 2, it is not a factor that will be among the factors making up 15,625 because our last digit is 5, so it is not an even number. Then 3, this is 1 plus 5, that is 6. 6 plus 6, 12. 12 plus 2 is 14. 14 plus 5 is 19. So we discover that 19 is not a number that is divisible by 3. So this number is not divisible by 3. So let us look at 5. Our last digit is 5. Then it means that the first prime factor that I have is 5. So 5 into 15, that is 3. 5 into 6, 1. We have a remainder of 1, which makes this 12. 5 into 12, that is 2 because of 10. We have a remainder of 2, and 5 into 25, we have 5. Our next prime number is still 5. 5 into 31, that is 6 because of 30. We are left with a remainder of 1. 1 makes 12. So 5 into 12, we have 2 because of 10. We are left with a remainder of 2. And 5 into 25 is 5. The next prime number is still 5. 5 into 6, that is 1. We have a remainder of 1, which makes this 12. So 5 into 12, 2. Because of 10, a remainder of 2. 5 into 25 is 5. Next is still 5. 5 into 125. 5 into 12, that is 2. We have a remainder of 2. 5 into 25, 5. So 5 into 25, we have 5, and finally 5 into 5, that is 1. So the prime factors making up 15,625 are 5 repeated 6 times. So we have 5 times 5 times 5 times 5 times 5 times 5. Then we want to get the cube root, so we group them into groups whereby we are having the number repeating itself 3 times. So the number repeating itself 3 times, 5 times 5 times 5, my cube in that number is 5. Then 5 times 5 times 5, my cube is still 5. So it means that my cube root 15,625 gives us a cube root of 25. So the cube root of this given number is 25. So let us confirm. Can I multiply 25 repeatedly 3 times and see if I'll get 15,625? So 25 repeatedly 3 times, that is 25 times 25 times 25. So 25 times 25, 5 times 5 is 25, so write 5, carry 2. 5 times 2, 10, 10 plus 2, 12. 5 times 2 is 10, so write 0, carry 1. 2 times 2, 4, 4 plus 1, 5. So this means if I add, I have 5 plus 0, which is 5. 2 plus 0, that is 2. 1 plus 5, that is 6. Then multiply by 25. So this is 5 times 5, 25. Write 5, carry 2. 5 times 2 is 10. 10 plus 2, we have 12. So write 2, carry 1. 5 times 6 is 30. 30 plus 1, we have 31. Then next, we have 2 times 5, which is 10. 2 times 2, 4. 4 plus 1, we have 5. 2 times 6, that is 12. So when we add, we are getting that we have 5 times plus 0, which is 5. 2 plus 0, that is 2. 1 plus 5, that is 6. 2 plus 5, that is 5. And then we have 1. So it means that the cube root, we have 15,625. So in conclusion, then the cube root of 15,625 will be 25. The next example we have is the cube root of 6,859. So we are getting the factors that make up 6,859. So 6,859. We've said that 2 will not be a factor because our last digit is 9, which is not an even number. 3, when we add, we have 3 plus 8, that is 14. 14 plus 5 is 19, and 19 plus 9 is 28. So 28 is not a number that is divisible by 3. So this means that this number is not divisible by 3. Next, we move on to 5. Our last digit is neither 0 nor 5. So it means that my number is not divisible by 5. Let us find out, is our number divisible by 7? 7 into 68, that is 9 because of 63. We have a remainder of 5 into 55. 55, we have 7 because of 49, that is a remainder of 6 into 69, that is 9, and we have a remainder of 6. So it means that this number is not divisible by 7. The next prime number I have is 11, and to get if the number is divisible by 11, then I have 16 plus 5, which gives us 11, then 8 plus 9, that is 17. So 17 minus 11, we are getting 6, and 6 is not a multiple of 11, so it means my number is not divisible by 11. So that is where my divisibility test knowledge ends. The rest, I'm supposed to use the division algorithm to find out if the number is a multiple, can divide the given number. So the next prime number I have is 13. We are finding out if 13 is able to divide 6,859. 13 into 68, we are having 5 times because of 65. So 65, we have a remainder of 3. So 13 into 35, that is 2 because of 26, and we have a remainder of 9. 13 into 99 is 7 because of 91. So we have a remainder of 8. So since we have a remainder, it means that 13 is not the prime number that I'm looking for. From 13, the next prime number we have is 17. So let us find out, is our number divisible by 17 or not? So 17 into 68, that is 4, which gives us 68. 17 into 5, that is 0. 17 into 59. Let us find out 17 into 59. 17 into 59. Let's see 3. This is 21. Carry 2, we get 51. So into 59, we have 3 times because of 51 and a remainder of 8. So since we have a remainder, then 17 is not the number that I'm looking for. From 17, the next prime number I have is 19. So from 19, let us find out. 19 into 68. 19 into 68. Let's see. 19 times 3, we have 27, carry 2, then 5 plus 19, it is more than 68, so it means 19 into 68, that is 3 times because of 57, and we have a remainder of 11. So 11, that makes it 115. So we find out 19 into 115. How many times? Let's see. 19 times 6. 9 times 6 is 54. So we write 6 carry. We write 4 carry 5. 1 times 6 is 6 plus 5 is 11. So we find that 19 into 115 is 6 times because of 114. We have a remainder of 1. So 19 into 19, 1. So we discover that 19 is the number that I'm looking for. So 19 into 6,859 is 361 times. So the next prime number will still be 19. 19 into 36, that is once, and we have a remainder of 17. So 19 into 171, we need to find out how many times is 19 into 171. So 19 times 9, 9 times 9 is 81. So write 1 carry 8. 9 times 1 is 9. Plus 8, we have 17. So this is 171. So it means 19 into 171 is 9 times. So that means 19 into 361, 19. So the next prime number is 19. And I have 19 times 19 times 19 as the factors that make up 6,859. I'm looking for the cube root. We said that a cube root is that number that is multiplying itself repeatedly thrice. So the number that is multiplying it repeatedly thrice in this case is 19. So the cube root of 6,859 is 19. Just a verification to find out if 19 multiplied by itself repeatedly 3 times, if it will give us the 6,859. So I have 19 times 19. 9 times 9 is 81, so carry 8. 9 times 1 is 9 plus 8, 17. 1 times 9 is 9. 1 times 1 is 1. So we end up having 1 when we add. We have 1 plus 0 is 1. 7 plus 9 is 16. So write 6, carry 1. 1 plus 1, 2 plus 1, 3. So 19 times 19, 361. So I have 361 multiplied by 19. That is the third term. This is once, twice, this is thrice. So 1 times 9 will give me 9. 6 times 9 is 54. So write 4, carry 5. 9 times 3 is 27. 27 plus 5. 27 plus 5 gives us 32. Then 1 times 1 is 1. 1 times 6 is 6. 1 times 3 is 3. Then we go ahead and add. 9 plus 0, 9. 1 plus 4, 5. 2 plus 6, 8. 3 plus 3, 6. So 6,859. It is the same with what we have there. So it then automatically means that it is true. The cube root of 6,859 is 19. So just like squares and square roots, you can have operations whereby you have several, the sums having combined the cubes and cube root, and you need to get the solution to the given sum. You've combined your cubes and cube root, and you need to get what is the solution to the given sum that you have. So an example could be, I'm having the following sums. So we are still evaluating the following. So I have this sum and I need to get, we are talking about cubes and cube root. So having cubes and cube roots, let us try and work out sums involving the cubes and cube roots generally. So we have 2 cubed plus 2 cubed plus 5 cubed. 2 cubed plus 5 cubed. 2 cubed simply means I multiply the 2 repeatedly 3 times. So I have 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Then plus 5 cubed is 5 repeatedly 3 times. So I have 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So that means that I have 8 plus 125. So 8 plus 125. 5 plus 8 is 13. Write 3, carry 1. 1 plus 2, 3. Then 1 plus 0 is 1. So it means that if I add 8 plus 125, it gives me 133. So the second example, we have 5 to the power of 12 divided by 5 to the power of 3. So what does it mean? What is 5 to the power of 12? We have 5, the cube root of 5 to the power of 12. So what is the cube root of 5 to the power of 12? Then the answer we obtain, we are supposed to divide by 100, the cube of 5. So we find out 5 to the power of 12 means that my 5 is repeated 12 times. So 5 times 5 times 5 times 5 all the way 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have the 5 repeated 12 times. Then we group them into groups of 3. Grouping them into groups of 3 gives me the 4 groups of 5 repeated itself 3 times. So in this case, my cube root is 5. Here, my cube root is 5. This point, my cube root is 5. And lastly, my cube root is 5. So what does it mean? The cube root of 5 to the power of 12 simply is 5 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 times 5 is another 25. 25 times 25 is 625. So the cube root of this number is simply 625. Then we are dividing by the cube of 5. The cube of 5 means that I have 5 times 5 times 5 repeatedly 3 times. 5 times 5 is 25. 25 times 5 is 125. So this means that this sum simply gives me 625 divided by 125. So we are dividing 625 by 125, meaning I can write my answer in a fraction form so that I have 625 over 125. Then we have common factors that can simplify our fraction. 5 into 625, this is 1. 5 into 12, that is 2. 5 into 25, 5. 5 into 125, 25 times. Then still 5 can simplify. 5 into 125, we have 25. 5 into 25, that is 5. Then if I simplify further, I have 25 over 5. So this means that 5 here once, 5 into 25, 5 times. So my answer is 5. So we are simply saying that the sum that we have, this is the sum that we are working out. That is the cube root of 5 to the power of 12 divided by the cube of 5 to the power of 3. And we are simply saying this is the same as 625 divided by 125. And the answer is 5 from our calculation that we've done. So from that calculation, we find that 625 divided by 125 gives us 5. So just winding up, we've been looking at cubes and cube roots. And we've simply said that a cube is that number that is obtained when you multiply the number by itself repeatedly 3 times. A cube root is that number that you are supposed to multiply repeatedly 3 times to give you a cube. So what is the difference? The difference between a cube and a cube root is the number that you are multiplying itself repeatedly to get a cube. But the cube is the number that is obtained after multiplying the number repeatedly 3 times, so that whatever answer you will be obtaining will be a cube. And we are winding up by looking at this, that if I'm asked to get the cube of 32, then it simply means we are getting the cube of 32. It simply means I multiply my 32 3 times. So I have 32 times 32 times 32. So this means that 32 times 32, we have 2 times 2, which is 4. 2 times 3, that is 6. 3 times 2 is 6. 3 times 3 is 9. So when I add, I have 4 plus 0, 4. 6 plus 6, 12. Write 2 carry 1. 1 plus 9 is 10. So I have 1024 times 32. So that 2 times 4 is 8. 2 times 2 is 4. 2 times 0 is 0. 1 times 2 is 2. 3 times 4 is 12. 3 times 2 is 6. 6 plus 1 is 7. 3 times 0 is 0. Then 3 times 1 is 3. So we add our figures, and we have 8 plus 0 is 8, 4 plus 2 is 6, 0 plus 7 is 7, 2 plus 0 is 2, and 3. So what does it mean? The cube of 32 is 32,768. That is our cube. That is 32 times 32 times 32 will give us 32,768. The reverse of that will give me a cube. The value for the cube root, I mean. So if I'm getting the cube root of 32,768, it simply means that it is the reverse of whatever I have. So if we are getting the cube root of 32,768, then it means I have to ask myself, what is this number that when I multiply the number itself repeatedly 3 times, I will get 32,768. And we find that the number that you multiply itself repeatedly 3 times so that you get 32,768 is 32. So the cube root of 32,768 is simply 32. So what are we concluding and saying? That if you want to get a cube of a number, multiply repeatedly the number thrice. If you want to get the cube root of a number, then you have to work the reverse way. Ask yourself, what is this number that when I multiply the number repeatedly 3 times, I'm going to get the value that I've been given. Then that number is what will give us the cube root. So it is important. Looking at the cubes and cube roots, it is just important that we have our knowledge, and that is why we started by finding the prime factors, and after getting the prime factors, we needed to find out when you have a composite number, what are the prime factors that are making up that composite number. So here we are just working with composite numbers, and these composite numbers, if I want to get the cube roots, then it means I have to work the reverse way and find out the prime factors making up the composite number. Then from the prime factors, can I find those prime factors that are multiplying themselves 3 times or thrice, so that the number that is multiplying itself thrice is giving me the cube root. So that is all we need to know about cubes and cube root. My advice is for you to be able to work out the questions easily. Can you practice more? Find out more questions and try and find the cube of the given question. Work out the reverse way and try and get the cube root of that given question. With more practice, the workings on cubes and cube roots will be easier for us. Thank you.